Hi, welcome back to NMI. This is a very special video for me because a couple weeks ago I became a Canadian citizen. Yes. So for this video I wanted to do something really special and something that is related to Canada. This is the reason why we're going to talk about the MCM 70. Here we have the MCM 70, and maybe you're wondering why I'm talking about the MCM or this machine in this video. Well, this is most probably the very first personal computer ever, and it was designed and built here in Canada. So I find that amazing. I first heard of the MCM 70 when I was doing a research on the Intel 8008, which is the CPU of this machine, and that's how it started. That's also the reason that I wanted to show you this machine, because it's not very well known, and I find that really sad that this machine, which is an amazing machine, it's almost forgotten in the computer history. So we're gonna take a look. Unfortunately, I don't have an MCM 70, but we're gonna take a look at its design, and there is a very nice emulator. I also bought this book, right? And the author, Zbigniew Stashniak, he is from the York University, the same university where this computer was born in 1972. So we're going to take a look at the history of the MCM 70, and then I'm going to show you an emulator written by the folks at the York University, and we're going to see how interesting this machine is. And we're also going to take a look at the language that you program this machine. It's very unusual, and it's called APL. Here we have a diagram that I created some time ago. I wanted to establish the history of microcomputers and microprocessors. And we can see here the Intel 8008, right? And it was derived from the data point 2200. So this was a terminal or computer system from the 70s, and the company wanted. So this was designed using discrete logic, right? And the company wanted to have the main CPU integrated as a single integrated circuit, right? So two companies tried to work on that design. One was TI with the TMX 1795, and the other was Intel with the 8008. So both chips were implementations, single chip implementations of this data point 2200, right? The TI was not very successful. It was very sensitive. It was very low tolerance for like voltage variations and stuff like that from what I read. So it didn't really move forward. But the Intel 8008 did was what it was expected from it, and it was successful, right? And while researching the 808 a couple years ago, I found that one of the machines that was like one early adopter of the 8008 was the MCM 70. But what I was really amazed was the fact that this was a Canadian machine, right? A Canadian design. And we can see here that Intel launched the 8008 in 1972, and in 1973 MCM was already shipping the MCM 70. And just to give you an idea, the first computers are personal computers. We're talking here about personal computers, right? Because there were other computers. But a personal computer, a small machine like this, the MCM is probably the first one, especially the first one with a single chip CPU. And then we see only in 1975 the Altair 680 and the 8800. These two machines, one based on the Motorola 6800 and the other on the Intel 88. These were only launched in 75, 2 years after the MCM 70. Not to mention that this is a self-sufficient computer, right? You have a screen there, right? You have a keyboard and you have two tape decks. Here you have just a couple buttons, right? And it was only in 76, for example, that Apple launched the Apple One. We're not even talking about the Apple II, we're talking here Apple One, 1976. So this gives you an idea of how advanced was the technology and how amazing this machine is. Let's have a look at some details on the Intel 8008, because as you can see here, that is a very small microprocessor, and it's very, very interesting, and I think it's worth looking into it. Here we have the datasheet of the Intel 8008, dated 1972. So the microprocessor has 18 pins on a dual inline package, 48 instructions. It's an 8-bit parallel CPU on a single chip. It can directly address 16K of memory, right? And they state here that it can be RAM, ROM, or shift registers. Let me zoom in here. This is a very classic block diagram. We can see the I/O. So the 8 lines here are shared by data and address. We have an arithmetic and logic unit, accumulator, registers and other stuff here, and instruction decoding and control. You can see that it has 2 clock lines and 1 sync line. Another interesting thing is that you can see here that it has 2 power lines, VDD and VCC. Is it, well, yeah, it's not stated here, but VCC, I think it's 5 volts plus or less 5%. VDD is minus 9. So so this is early days semiconductors, right? And it uses a negative voltage as well as a positive voltage. And here we have the 2 clock lines already. This is used for like lower speed devices to cause the CPU to wait until they're ready. We have an interrupt line and 3 CPU state outputs and a sync output, and then the 8 data and address line is here. Oh yeah, there is a picture of the die, which is pretty cool. I love seeing pictures of ICs and dies. We have the 8 possible states that the CPU can be, right? And then we have a timing diagram here. Well, and then like, yeah, we have the instructions, how they operate, and so on, right? So again, very simple, but very effective and very advanced for 1972. This was a very advanced microprocessor, right? Now, oh yeah, here is what I was talking about. Yeah, so VCC plus 5 and VDD minus 9. Yeah, now we're gonna have a look at the inner of the MCM 70 and some details of its architecture that are really interesting, and for sure you're gonna be amazed. We're looking at the same picture that we saw before. This is the MCM 70, and these pictures are from the vintagecomputer.ca. That is a museum, I believe. Um, so the MCM 70 had a single line 32 character display here. This is a plasma display, right? And one very interesting fact about this display is that it is an auto scanning display. So it's memory mapped to 222 bytes in the main or in the RAM, right? So that whatever you write on those positions is displayed on the on this display, right? It's presented on this display. And then one interesting fact of this machine is, and we're gonna see that even on the emulator, is that because the machine doesn't have a lot of memory, sometimes they have to reuse the display memory as temporary memory, so, or scratch pad. So what the software usually does is that you're going to see a lot of garbage on the screen while the machine is performing the calculations. So that's because the operating system is reusing the RAM, or that the display memory, as scratch pad memory. And once the calculations are done and the program has a result or something like that, then the display area, or that memory area, it turns back into display area, and then they write what you want to present, and then the display is not going to display garbage anymore. It's going to display what it's supposed to show, right? The machine also, there were different configurations. There was a configuration with no cassette, and a configuration with one cassette and with two cassettes. These cassettes, they're also very interesting. They are used for data storage, right? Just like what we see on the later machines. But one very interesting part of, or feature of these cassettes, is that they also work as virtual memory. So not only they store data in a non-volatile way, but they are an extension of the RAM. So when the machine needs to free up memory to perform calculations or to run more complex programs, it is going to move unused stuff, unused data onto the cassette, right? And then perform the calculations with the memory that was freed. So that is very neat, very interesting, and a concept that was not very common, even on the personal computers that came after the MCM, right? Oh yeah, another very cool fact about the MCM 70 is that it also had an internal battery, and the machine could detect power failure, right? And then it would save automatically the contents to a tape if a tape was mounted. So that I find also that amazing. Very few computers, even for like several years, very few computers and personal computers had a feature like that, and the MCM 70 had this feature. That's pretty amazing. Another very distinct feature of the MCM 70 is the keyboard, right? And we're gonna take a look later, but this keyboard looks similar to what we are used to. It's I don't know, 50 something keys, but you can see that they have a lot of symbols, right, on the top that are not very common. And that is because this machine is programmed in a language called APL, which is basically a mathematical language. And I'm going to tell you, I am a C guy, and I thought I never heard of APL until, I don't know, a few years ago. But I never really uh, looked into APL. It was only when I decided to do more research on the MCM 70 that I started digging into APL, and I'm gonna tell you, it is mind blowing. Like, I thought that, oh, how hard can it be? I programmed and I learned a lot of language by myself, but APL is something else. It is completely different from most language that I have ever seen, right? And the main reason are these symbols, right? Because APL, well, we're going to talk about that later. There is another thing, like since we're talking about architecture, oh, here we have a picture of the display, right? And it's pretty cool. Um, On this website, we can also see the boards of the APL. So this is the power supply, and this is an this is an I/O board. At first, one could think, oh, this is the microprocessor, right? This is the larger IC, but that's not true, right? This is the CPU board, and this is the microprocessor here, right? This is, let me zoom in. See there? This is the 8008. So, yeah, it's unusual to see a microprocessor this small. I mean, usually they have a lot more pins, but these were the early days of computing, right? And I don't really understand or know why Intel decided to design a microprocessor using a few pins. For sure, they changed their mind with the 8080, because the 8080 has 40 pins, right? But the 8008 has only 18. This is the RAM, I believe. Yeah, this is the memory board. Yeah, like it's a lot of chips, right? This again, early days of computing, so very low capacity RAMs. This is for maybe only 8K, right? And this is the ROM board. So as from what I remember, each ROM here is 2K, right? I don't know if I mentioned, but this machine has 32K of ROM and up to 8K of RAM. And it implements a paging system to switch between all these memories, because as I mentioned before, the 8008 can only address 16K of memory, right? So these are the two cassettes. Did we get? Yeah, so this is the front picture of the cassette decks, and this is the back picture. Fairly complex circuitry. And this is the keyboard. Again, I think this is the better picture of the keyboard, and we can see here all the symbols, right? So the keyboard is very unusual, and these symbols, they have very special meaning on this machine, right? One thing that we can I can tell you right away, for example, the 4 operations plus like addition or summation, subtraction, multiplication, and division. This is the divide symbol for the division, as in math, right? And this is the multiplication symbol. So we are used to use asterisk, right, for multiplication, for example. But no, on this machine, multiplication is this small x. This asterisk here has a completely different meaning. Oh yeah, and this is the display. Oh yeah, there's no other picture of the display. But this is a picture of the side of the plasma display. Oh yeah, on this website there is a video of this MCM 70 that they own, and they type and test a game, a horse game on the MCM. So I'm gonna play the video quickly here. See, this is how you type and type in a program on the MCM, and this is APL. So the first line of the program. See the symbols? I have the listing of this program. We can see it. Yeah, but it's starting to get enigmatic already. Look at this. Line 2. Yeah, there we go. Symbols. It's interesting that the language is so high level, so powerful, that with very few symbols you can do a lot of stuff. Let's move forward a little bit. Line 5. Okay. That is not divide. almost there. Oops. So let's see, the last line, then 16. Yeah, this symbol ends the program. Yeah, so now we're back to the like input. This is the, see, this is the garbage that I mentioned, right? It's pretty cool. So this is the computer thinking or the processing, right? So these are the horses running, each at a time. And then while the computer performs the calculation, we see garbage on the screen, on the display. Yeah, let's move forward a little bit. Yeah. Yeah, let's just move back a little bit to see number 2. Yeah, number 2 was there. 3, 4, 5 was behind. Yeah, and then 2, 1. And the winner by a nose is number 2. Pretty cool, isn't it? We're almost there. Almost at the point where we're going to take a look at the emulator. But before, I wanted to show you this page from the York University Computer Museum in Toronto. And here there's a lot of interesting facts and history. One thing that I find very, where is that? That I find very interesting is that, look, the price of this machine, the MCM 70 in 74, 75, was between $4,700 and $9,800, right? But that is 74 Canadian, 1974 Canadian dollars. So that is a lot of money even today. But if we do the calculation here, and I use this online website, $9,800 in 1974 is the equivalent of $59,000 today. So that is hardly a personal computer. Anyway, yeah, well, it's the price of Vanguard, right? Like that was bleeding edge technology in the 70s, right? So anyway, yeah, that's I find that interesting. Again, is this the personal computer? I don't think an ordinary person would be able or afford to buy such an expensive machine, but who knows, right? Anyway, it was small enough and accessible, not in the financial way, but it was a machine that could be used by ordinary people as long as they were rich, right? So yeah, so now let's take a look at the emulator. In order for you to get access to the emulator source code, you have to contact the York University Museum, and there is a contact in their website. There's that is if you want to really compile the code and run the code locally. Also, on their website, you can have access to the, let me show you, the user's manual, the MCM 70 user's manual, which is pretty cool. It's really interesting. So I was reading it and I was learning about the machine. They have, let me show you here, the keyboard. So with all the symbols, they explain how you use the machine, which is very important because very few people would know how to operate a computer in the 70s, right? Um, So they explain all the operating modes and the symbols. It's very nice because it starts from the very basics, and then it dives into like more complex stuff. um, I can tell you that by what I read from this manual, and now the very little I know about APL is very powerful, and you can write complex programs with very few lines of code. Of course, they are going to be very cryptic for people that don't understand APL, such as me or such as myself. But you know, if you understand APL, I believe it's an extremely powerful language. Um, I also found, let me see, where is that? So they, on page 230, yeah, here, 238, we can see the all the special symbols and their meaning, right? And that's where we find this del for mode change, for example, and this quad, which is used for input and output and so on. So very cool. If you are interested in learning more about the MCM and maybe learning a little bit about APL, even though this is older APL, I understand that APL continued to evolve, and there are newer versions, and they implement a lot of other stuff that is not mentioned in this manual. So this is one, and then on their website there is also the MCM70E, because this is from the emulator, right? So MCM70E, it's the emulator manual. So this is the how the emulator looks like. This is obviously the original machine, right? Oh, I can't. So yeah. So the emulator even emulates the operation of the cassette tapes and everything. Um, in order for you to install or like compile the emulator, you need the OpenGL and GLUT or free GLUT libraries. Let me show you. Well, before we go there, let me show you something else. This is if you want to run the emulator and compile from source and run it locally, which is pretty cool, by the way. And maybe I'm gonna show you later, but there is even a gentleman from Waterloo that built an MCM using a Raspberry Pi, but he managed to replicate the display, keyboard, and everything. And then he used this emulator inside the machine on a Raspberry Pi, right? So probably that's the closest you can get, unless you decide to replicate to some extent the hardware, right? Maybe that could be a very interesting project for the future, right? Rebuilding an 8008 using a small FPGA and so on. Who knows? Like maybe it's something for the future. But for now, if you're not interested on running it locally, the other option is to go to this website. So someone ported the C code of the original emulator to C sharp. And then here, you have the source code available on GitHub. I'm going to link there on the video description. And then here, you can run. Can you? Yeah. Loading. Okay. So here they have a few tips um, of like how it operates. And then where's the link? Oh, here on the very top. So you have to click on this link on the very top, and here we are. So this is the emulator. I'm gonna press this button, and now the emulator is running, but the machine is sleeping, right? So we need to press start, which is tab on the keyboard, and then now the machine is running, and if I press enter, yeah, so we're on input mode now, and let me see what we can do. Well, as I mentioned in the like previously, we are now in the execution mode. So if I type 2, what is the key for plus? Oh, it's here. Plus 2, enter. 4, right? So it's in like in an interactive mode. So again, the keys on this virtual keyboard there or on the real keyboard, they do not map to exactly the same keys on the PC keyboard, right? So on my keyboard, besides the 0 here, I have minus. Here it's plus, and beside that I have equal, but here it's multiply, right? But so the idea is the same. I'm not gonna spend too much time here on this emulator because I want to run the emulator locally. But if you want to do it here, this is the website, and this is how you can easily have access to the MCM70 emulator. Now here we have, oh yeah, I'm talking, since I was talking about the gentleman that rebuilt or built from scratch an MCM70, this is the project, right? Oh, there is another one on instruct tables. Isn't there? Yeah, but anyway, this is the project, and you can see it's pretty cool. So he built a keyboard. He used the emulator. Here you can see it all based on the York material. This is the enclosure, right? The display. He obviously he ended up having to use a different display because the original display it's very hard to find and operates on higher, like very high voltage. I think it's 250 or 300 volts. So yeah, but it's an amazing project. Even the cassettes, they're not fully operational, but he mimics them pretty well. Yeah, look, it's an amazing project. I'm gonna add the link to this website as well on the video description. Now let's go back to command line here. So as I was saying, oh, let me get the hints for the emulator. Without them, I am nothing. Let's see. Yeah. So here you have the hints for compiling using GCC, so that only works on Linux, right? Or if you have Windows, you're gonna have to figure out. The code includes the ROMs, right? Here is the keyboard mapping for the keys, because as I mentioned, APL has all these symbols and some keys are in different places. Yeah, here he's talking about the garbage on the screen that we already mentioned. Oh, here he mentions 222 bytes. So yeah, probably I wasn't wrong, and that's where I got this information. Oh yeah, mounting the tapes. Okay, so let's start by, I have the, well, let's compile it again. Oh, okay, now I'm on the right directory. And if we, I already have MCM here, as you can see, but if we use that command line for GCC here, we should be able, yeah, there are some warnings, but it compiles fine. And then if we use this here, we have the, let me just make sure that it's correctly showing on the screen. Yeah, so here we have the emulator running. I'm gonna, let's see if we press start. Yeah, so it's running MCM APL, right? And I can press enter, and I can do the same thing that I did on the, I just need to be careful because the keys are different sometimes, and like I'm gonna probably make some typos. But here, yeah, see the garbage on the screen. 5 times, oops, okay, 5 times 5. See, this is the multiplication on APL, 25. If I try 5 after, what is where on top of P? So 5 asterisk 5. See, it's a completely different thing, right? Now APL, you need to change your mindset a little bit, but it's pretty cool, right? So let me see what we are gonna do. Oh, I'm gonna move this window, this to another window. Is it looking fine? Let's minimize this, and I need my hint on the other side, so I'm gonna keep looking that side. I apologize. So yeah, the MCM has an OS, right, built-in, so that we can manage like the tapes and everything. So let me see the command for loading a tape formatting. So first we open the tape by clicking. It's super cool, right? Uh, the folks at York University, they went above and beyond. So even the tapes here, you can click to open and close, and then when they're open, you can load the tape here. I'm gonna load this demo.tp. Isn't that cool or not? So okay, now I have a tape there. I'm gonna close it, right? And I'm gonna, like, let me see the command for what is the command? Loading all objects, listing the content of a group, listing all groups on a tape. So it's, the command is a quad. Quad is on top of L. So quad XN, and then I don't know if there's a space, and then iota, and iota is on top of I. Iota 0. Let's see if that works. Thinking. The tape, the tape is spinning. Oh, that is super cool. Okay, thinking, there's garbage changing on the screen. The tape is spinning. Okay. Oh, there is a bunch of stuff. So this we're seeing here are the groups. Yeah, I confess that I didn't read the whole manual. I know that things are organized, like the groups are kind of, from what I understand, like the directories inside the tapes. So each group can have a number of files inside. Um, I don't know which group we are interested. Let's see, and then we can list the content of for a group. So okay, X and okay, so let's see. Oh yeah, we type enter, then you show the other part of the, like, more groups. Okay, we're back to the execution or mode, right? Now again, quad L X and let's see if I don't recall if we have a 10. I don't think so. There's nothing there. I recall that there was a 1. So quad xn 0. Okay, 0, there's stuff in this group. Get cp grp gr cr dx rl, a lot of stuff. Yeah, let me see. I want to see games, but let's see if the manual here shows group and tape. Oh, it's the group 80. Okay, so quad xn 80. Okay, let's see if this is the right command and the right thing. It's still thinking. The tape is spinning. Garbage. Okay, we have add AGG ALP CD CLE CRA C day D delta F delta F G0 gun hang hit whore. Okay, that is probably horses. Okay. By the way, as far as I know, this is the actual speed of the machine, right? So I don't know about the tapes, but I want to believe even the tapes are emulated with the correct speed. Okay, so we're back. There is what there's horses, so it's what is the G? So on top of G we have del hor. Let's see. Oh, no. That's not what I wanted to do. I don't want to type a program. What should I do to cancel this command? It's okay. Now I want to run. Oh yeah, there's another thing. He on the manual they mentioned that you can use quad XS80, so we can mount this group 80 as a virtual memory. That's insane, right? So now then all those programs, they're going to be accessible on the memory. So the tape is spinning. Yeah, it's spinning. Garbage is not changing. All small changes to the screen. Yeah, that's not very fast, but come on. 1973, right? 808 running at 800 kilohertz. What do you expect? I find that still amazing. It's quite fast for a machine running at 800 kilohertz. Come on. It's okay. So let's see. Oh yeah, they mentioned here that there's hangman. Okay. So if I just type hang, is that gonna work? So hang. Yeah, see garbage changing there. Oh, a lot of stuff happening here. Tape is spinning, right? Because still, it doesn't mean that all the programs were loaded into the memory. It's virtual memory, so the machine was just aware that those programs now are supposedly inside RAM, but it's only when you run the command is that it's going to load what it needs into the actual or physical RAM, right? New message. Okay, so we have a program running. Okay. Okay, computing. Garbage changing. Okay, we have a word. C space C space blah 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 R. Now, which I'm gonna try A first. So okay, I press enter, and I'm gonna try A. I have no idea how to play this game, right? So age. What does that mean? Is this correct? I'm gonna try O. It's funny that O looks like a zero. Oh, okay. Because there's no way they're gonna draw the hangman, so they start. So I'm making mistakes. So A and O, they're wrong. Okay, what else? I'm gonna try E. I'm gonna try E. At some point, I'm gonna have to, because it needs to have. Oh, okay. C, C, English is not my first language, right? So, but okay, that's not an excuse. Um, what can it be? Okay, I'm gonna try. So I tried A, I tried O, and E. I'm gonna try I. I still don't have any idea of what is that word, so I'm gonna try I. No, that was wrong. Okay, I'm gonna try you. You. Oh, oh, cucumber. Okay. Yeah. Okay. And now the last one is B. See? Yeah. Let's press enter. What happens? I think we're gonna have. Yeah. You win in 7 guesses. Well, I think that's it. Uh, it is amazing, right? So if you had, well, just let me. Yeah. If you had um, $9,800 in 1974, you could play Hangman on your own computer like this, which I think it was pretty cool. A little bit expensive, this kind of video game, but of course, this was not the main use of this machine. Those were different times, and again, maybe it was not super affordable, but we are talking probably here about the very first personal computer ever, and the very first one using a microprocessor. And so I find that amazing. And most importantly, this is Canadian, right? A machine that was designed not very far from here. I'm in London, Ontario. This machine was designed in Toronto, so like about 200 kilometers from here. Amazing, right? And it's as old as me, slightly older than me. Um, anyway, I don't know if you liked it, but I really find it impressive, right? And I love these history facts on computing, right? So again, thanks for watching. Happy Canada Day. This is a piece of Canadian heritage, and I hope you keep watching my videos, and please subscribe, like this video, and see you next time. Bye.